Friends, welcome back. Today's presentation is on normal distribution, and we are going to study normal distribution along with its application in different types of business related problems. Earlier, we had studied about binomial distribution and Poisson distribution. Binomial distribution and Poisson distribution are both discrete distribution, but normal distribution is a continuous distribution. By continuous distribution, we mean that the random variable x, which we are concerned, can take any value within a given range, and the normal distribution actually addresses such variables. So friends, I am your professor Dipojyoti Bhattacharjee, and I am from the Department of Statistics, Assam University, Silchar. So here we go. So let us see what we shall cover in this presentation. In this presentation, we will understand why normal distribution is important for business research or in business studies. We'll define the normal distribution. There is a standard normal distribution as well, which will also look into. And we will see the key properties of normal distribution. We'll understand the parameters of the normal distribution, which is mean, represented by the Greek letter mu in smaller case, and the standard deviation, which is represented by sigma. Both these decides the shape of the curve of the or the normal curve. So mean and sigma, that is mean and standard deviation, are the parameters of the normal distribution. Also, the normal distribution has an interesting 68, 95, and 99.7 rule, which gives a quick understanding of the empirical area under the normal curve and its distribution. We'll also look into how normal variables can be converted into the corresponding Z scores, and we'll look into some real life problems uh, on where normal distribution can come handy and solve problems related to finance, related to operations, and related to marketing. Okay, now let us look at why this normal distribution is important in business, or in which area of business we can actually gainfully use this normal distribution. Now, normal distribution can be gainfully used in human resource performance, where we can actually find out the given the performance of a large group of employees of an organization, we can find out which employee is at what level of performance. That means it can be utilized for performance rating. We can understand the salary distribution, that is how the salary is distributed amongst different employees of an organizations. Or if we perform an aptitude test to understand the seriousness, sincerity, performance, etc. of a group of employees, then we can classify these aptitude scores and understand which employee stays at which level in terms of their aptitude. In operations and manufacturing, we can use these for normal distribution for understanding the or comparing the different dimensions of the manufactured product, and we can find out the uh, products or the units which are at the best level of production given different dimensions or a single dimension of qualification. It can also be utilized to understand the service process time whenever you go to take a service. It also can look into the inventory demand levels, and then inventory management. In the field of inventory management, this normal distribution is quite often utilized. In finance and economics, this can help us to understand the returns on different financial assets. It can help us in projection of different sales figure, and it can help us in actually combining different economic indicators or finding the distribution or classification of different subjects or entities based on the values of a single economic indicator or a number of economic indicators. In marketing, it can be helpful in understanding or grading the annual spending of customers. And then it can also be utilized to understand that when an individual visits a particular website, what is the time period for which the individual is expected to stay in that particular website. Or we can extend it to some generalized comments like this particular website is visited for a time period of more than uh, 10 seconds or more than 10 minutes, etc. So like this, we can find out the chances of all these types of statements. And these can also be used for product rating that the customers makes about the different products. So these are, in a nutshell, about the different applications of normal distribution in business research. This is the applications are not limited to these few heads only. There are innumerable number of fields where we can apply normal distribution in different types of business studies. Now, the normal distribution is a bell-shaped curve. That means we have different values of x. So if we take in the x-axis, along the x-axis, and we take the probabilities of the different values of x along the y-axis and plot them, then since the distribution is continuous, so they are connected by a freehand smooth curve. And the shape is what you are seeing in front of you. So if you look at this particular shape, then this gives us an idea about the normal curve. As you can see here, the curve starts from here, goes up. So this is the normal curve, what you are seeing. This and comes down. I cannot completely align to the curve, but this is now if you look at this, why it is called as symmetric curve. It is called a symmetric curve because in this curve, the mean lies actually at 50%, what you are seeing. At 50%, this is the mean. So the mean of the distribution is somewhere here. And there is a line, say this line, this dotted line. If you fold the curve along this dotted line, this side and this side will actually tally with each other and they will exactly fall on each other. This is what the meaning of the symmetrical bell-shaped curve. And then there is a nice graduation that if you look at this here, the photograph actually tells about the performance level of different employees in an organization. And if you visit a randomly into any organization, you will find that very serious underperformer who never performs will be very less in number, and very excellent performer will also be very less in number. The clustering of the employees will be around this meet expectations group. That means most of them will somehow manage to meet the expectation. So you will find that most number of people are in this particular range from this line to this line. However, at the end, the curve tapers off, and at the end, there are very few people who are in the extreme cases. So that's why normal distribution is very spatial and very specifically defined. So let us go forward. Now, in this stage, we are now in reached a stage where we can define the normal distribution. A normal distribution is a continuous probability distribution. We have been seeing it also and telling it also from the beginning. A normal distribution is a continuous probability distribution that is perfectly symmetrical and bell-shaped around the mean. So just now we show the diagram, and in the diagram we have understood this, that it is a normal distribution is a bell-shaped curve. It's symmetrical about the mean. The mean, which is represented by mu, is the center of the distribution, and the standard deviation determines the spread or width of the distribution. Notationally, we write, if we want to tell that x is a random variable which follows normal distribution with mean mu and variance sigma square, then we write it like this, that random variable x follows a normal distribution with mean mu and variance sigma square. Sometimes we tell variance sigma square, sometimes we tell in terms of standard deviation. In that case, we tell standard deviation sigma. So in this way, so either we tell this or we tell this. Okay. Now, next step, we go forward. The big picture of the normal distribution. What we have seen earlier, with where we had the uh, performance level of the different employees. So that's we get a clear picture here without any animation in between. So this is the normal distribution. This is an example we have taken where we assume that the mean of the normal distribution is 1150. So this is the mean, and the standard deviation is probably 150. So mean plus standard deviation, that is mu plus sigma, that comes out to be 1300. Then we have mean plus twice sigma is 1450, and mean plus thrice sigma, this is mu. Mu plus thrice sigma is equal to 1450 plus another standard deviation. So your standard deviation, remember, is equal to, in this example, 150. So it increases in terms of 150 every time, and it decreases this side, it decreases in terms of 150 every side. So this is actually, we have here 34% under this curve, this area, this particular area under this curve. That means if this area is 34%, it is symmetrical. So this side also same area will have same probability. That is, here also probability is 30%. That means in total, the probability of random variable x lying between mu plus sigma and like mu minus sigma, this probability is equal to 68% or 0.68. So this is 68%. So this area is 68%. Okay. Now we have, if you go to mu plus twice sigma and mu minus twice sigma, the probability of mu minus twice sigma less than x less than mu plus twice sigma, that probability will be equal to, already we had 0.68 and then 13.5 and 13.5. So 13.5 plus 13.5 is 27. So if you add this with 27, so 0.68 already we have, plus this is giving you 0.27, so that will give you, here you see you will get 5 here and 995, so this is the 0.95, and then you use 2.35, then you get almost very close to 1, and that's why this rule comes from there. We have mentioned about this particular rule which we have seen that, well, where is that rule? Mm, Yeah, this is 68%, 95%, and 99.7%. That rule is actually, this is what we have done just now. Okay, this one. You see, first one is 68%, second one is 95%, and last one, if we add, like we have probability of mu minus thrice sigma x, comma mu plus thrice sigma, then that probability already we have 0.95. 0.95, then this is 0.235 plus that side once again 0.235, so that will give me 99.7, or sorry, this will give you equal to 0.997. So that is how this graduation takes place. This is how the curve is divided or well graduated. This will happen surely for a normal distribution, but there are other probability distributions also which does not have such a symmetrical form, like gamma distribution, beta distribution, exponential distribution, etc. In that case, so beautiful way of demarcation will not take place. Mu plus sigma, if you add the mean and the standard deviation and then take away the standard deviation from the mean, mu minus sigma and mu plus sigma, they will not have produce 0.68 probability. It happens only in case of normal distribution. Okay, let us go to the next one. Now let us see that when we change the mean and the standard deviation. In this example, we have kept the standard deviation fixed at 4.2. Okay, and then we have seen that how things changed, because here you see this also standard deviation 4.2, this one also standard deviation 4.2, and this one also standard deviation 4.2. But if you look at the mean, you see here we have taken mean at 10. So here you see your distribution having peak at around 10. So it is just like this. You will see height of the peak and the spread of the peak is same, because the standard deviation is 4.2. This is also having a spread of 4.2 by standard deviation. This is also spread is same. That's why the curve looks to be very much same in terms of its spread. But look at the mean. You see now as we give 12.5, the mean has now shifted from 10 and it has come to 12.5. So some shifting has taken place. Here you see you get the top at 10 and here you get it top at 10.2, sorry, 12.5, because you will get it corresponding to its average. This has an average of 14. So you see the peak is coming at around 14. So this is your 14. So peak is coming around 14, and so this the three distributions, all of them normal, all of them have the same distribution, but their averages are same. Since the averages are same, so there is a shift. There is a shift in the graph like this. Now, if you come here, so your standard deviation, look at the standard deviation here. If you come here, here a standard deviation, this one is having 3.2, this one is having standard deviation 4.5, this is having a standard deviation of 6. But the average is same. So you see here also the peak is coming around 12, this one. Here also peak is coming around 12. Here also peak is coming around 12. So the peak is at the same place. But look at the three figures, you will understand The spread is different. This is having a less spread because here standard deviation is less compared to this and this. And as you go to 6.2 standard deviation, you find that the spread is more. So this is how the thing actually works. Now, let us try to understand more about the mean and sigma. First thing is that a mean is represented by mu and sigma is represented by the standard deviation. And mean is called as the location parameter. This is the peak. This is the value of x at which you get the peak. This is the average value and this is the expected value. That means if you take the average, say, for example, here we take about talk about the daily sales. So daily sales, we are talking about the daily sales. Now, suppose you have daily sales data for large number of days. Now, if you take the average of daily sales, that approximately gives you the value of mu. And there where you will find the peak in case the data follows or the random variable x follows normal distribution. You will find that there is a clustering of values about the average, which is taken around a large set of daily sales, large number of data points. Okay. Now, standard deviation, this is called as the scale parameter. It measures the average distance of data points from the mean. So, if the average distance of data points from the mean is more, you will find that the spread of the normal distribution is more. In business, it is used to quantify the risk or volatility or consistency. Means if the spread is less, consistency is more. If the spread is more, consistency is less. More risk means more spread. More volatility means more spread. So low value of sigma means high consistency, low risk. If you look at a stock, if you calculate the value of sigma, that is standard deviation, then if the standard deviation value is less, that means the price of that particular stock is consistent, not much vary. But if the value of sigma is high, that means it is highly volatile. It may go up and come down very rapidly. So these are some more discussion on the mean and standard deviation. Now, this is what why we were calling the 68, 95 and 99.7 rule. Now, if you look at this, once again, we have seen that, well, we have discussed it earlier also. That means from this point to this point, sorry, from this point to this point, the probability, that means the area under this curve, that is means area under this curve, including this line, taking the baseline this and going up to this, that is 68%. That is 68%. And then it starts from here and goes up to here. This particular range of values from here to here, this comes out to be 95%. And if you compare this, hardly anything is left after the curve. So if your data follows normal distributions, it is highly unlikely, 99.7. It is highly unlikely that you will get some value outside the range of mu minus thrice sigma and mu plus thrice sigma. I repeat it. If you compute the mean, if you compute the standard deviation, then you can compute this as well as you compute this. Then there is hardly any chance of your random variable x to fall outside this range. Suppose this is say this you have got say 2 and this you have got 7, and then the probability that x will follow outside this range, outside 2 and 7, getting any value outside 2 and 7, that chance is really very less in case your data follows normal distribution. Okay. Now let us start with a problem. Here there is a problem and the problem is related to the control process in manufacturing. A company produces bolts with a mean length of, let me take a white pencil so that, okay, with a mean length also, here is your mu 50 mm and a standard deviation of 2 mm. So this is your standard deviation. Lengths are normally distributed. What is the percentage that this lies between 48 and 52? So this is your mu, this is your sigma. So what you start probability of, because this is the range, so you start your problem with this 48 and 52, 48 and 52. Now, here you see your mu is 50, sigma is 2. So if you make mu minus 2, that is 50 minus 2, you get 48. And then 50 plus 2, you get 52. That's what I am writing. And then I am writing instead of mu 50, I am writing mu, instead of 2 I am writing sigma. So what I am getting, I am getting that I have to find the probability that this x lie between mu minus sigma and mu plus sigma. And then this is actually 34, and this is also 34%. Mu, that x lying between mu minus sigma and mu plus sigma, that is 34%. So 34%, if you what is 34%? 34% means 34 divided by 100. Since probabilities are numbers between 0 to 1, so instead of writing 34%, we write 0.34, 0.34. So if you add them up, it is 68. So percentage of balls lying between this, just express this value as percentage, multiplied by 100 and put the percentage symbol. So 68% of the values will lie within the range of 48 to 52 mm. So that is how we solve this particular. Let us now look at the standard normal distribution, which is also called as Z distribution. Now, our normal distributions can take any mean. It can actually take any value of mean from minus infinity to plus infinity. And standard deviation, since it is a positive quantity, it can also vary, but from 0 to infinity. So, with the changes in the value of the parameters, earlier also we have seen in the graph that even if the mean is fixed, standard deviation is varying, we get different types of curves. If the reverse happens, like mean is varying, mean is fixed, standard deviation is varying, then also we get different types of curves. So that actually, in such a situation, what happens? We cannot compare them directly. So in order to bring in a comparison, a distribution is there, which is called as a Z score. That means if I can convert any normal distribution, X is a normal distribution, to Z score by this transformation. X minus mean, that is divided by the standard deviation. That is, if mu is the mean, then X minus mu divided by sigma. Now you see, your mu value is fixed, your sigma value is fixed. Now X will take different values. So X is taking 2, 2.7, 2.9, like this. X is taking different values. Now if you keep on putting X here, 2, then 2.7, then 2.9, like this, mu and sigma remains the same. So correspondingly, you start getting different values of Z depending on the value of mu and sigma. Now, this exercise we can do. Why? Because this Z distribution also has the same graphical form as that of the normal distribution. So this is also a normal distribution, but this normal distribution has now mean of 0 and standard deviation as 1. So this is also a normal distribution with mean normal distribution with mean 0 and variance 1. Now, whatever be our mu and sigma, what in case of our random variable, when we convert the Z score, all of them follows normal distribution with mean 0 and 1. Because normal distribution, as we have mentioned, have a very nice graduation properties. That means we can, that is the 68, 95 and 99.7 rule. So that is abided by the Z distribution. Such a distribution is called as the standard normal distribution. And it is easier to interpret also, because it follows that the Z score of 1.5 mean, that means 1.5 standard deviations above the mean. A Z score of -2 means 2 standard deviations below the mean. So that's how, for example, if you have a Z score corresponding to this, suppose you have a Z score of 1.2, that means it has stationed itself in such a place that there were 1.2 times the standard deviation above the mean. So that is the meaning of this, that this particular value is 1.2 times standard deviation above the mean. So this is because mean is your 0 when we go to Z score, standard deviation is 1. So 1.2 means 1.2 times standard deviation above the mean is 0. So this is actually makes an universal reference scale. So if you want to compare that, okay, well, for example, suppose I have given a test in a particular paper, means many people have given a test. Suppose that test was from 0 to 10, within a range of 0 to 10. Okay, within a range of 0 to 10. Another person has taken a test which is from 0 to 35. 35. So this is a Y. Now I want to compare the performance of these, my performance or anyone's performance in this paper and this paper. Now, well, we can actually convert it from 0 to 10 to 0 to 35 scale. But instead of doing this, if you compute the Z score, Now, Z score can be directly compared. Suppose Z score, first person got a Z score of 1.2, second, and the same person gets a Z score under this paper as 1.4. You can directly tell that he is performing better. The same student is performing better in Y than in X because the Z score is more. So we don't need the reference of the range. We don't need the reference of the mean. We don't need the reference of the standard deviation. But directly we can compare through Z score. Obviously, we assume that they follow normal distribution. Okay, so that is the advantage why we convert sometimes our random variable to corresponding standard normal distribution. That is the Z distribution, also called as Z score in some by some authors. Okay, now this is why Z score is very important. Like here, what we have is that this is now here you see this is the standard normal distribution, same type of curve we have got. But look at the beauty here. Let me change the color of the pen once again. Let us look at the beauty here. Here you see the mean is around 0 and mean plus standard deviation. You see mu plus sigma, mu plus sigma. What is this? Is mu plus sigma. But what happened? How why it became 1? Because your mean is 0 in this case mean is 0 and the standard deviation is equal to 1. So we have this here mu plus twice sigma. So what is mu plus twice sigma? Mu plus twice sigma, mean is 0 plus twice sigma is 1. So this is equal to 2. So that's the reason why we get 1 2 3, and that side we get minus 1 minus 2 minus 3. So this makes our comparison very easy irrespective of the type of distribution. So this is you can sigma times. So here how many times sigma minus 3 times minus 2 times minus 1 times. So that's the standard normal distribution. Now let us look at the properties of normal distribution. First property is that normal distribution is a bell-shaped curve. It is symmetrical. It is defined by the mean mu and the standard deviation sigma. So mean and sigma are the mean and standard deviation of the normal distribution. For the normal distribution, the mean, the median, and the mode are identical. So they have identical numbers. Mean, median, mode means they are same in a normal distribution. So if mu is given to be 5, so median will also be 5 and mode will also be 5. There is no point of computing because they are exactly the same. Sigma is the measure of risk or volatility. That means a large value of sigma means that uncertainty in the value of the variable is more. And the Z score standardizes any normal distribution value, allowing the comparison against data set which is a mean of 0 and standard deviation of that is 1. It is a well graduated curve in terms of mu plus minus sigma, mu plus minus twice sigma, and mu plus minus thrice sigma. And you have already know that this is 68% till mu plus minus sigma. This is 95% from mu plus minus twice sigma, and this is 99.7% for mu plus minus thrice sigma. And it is the cornerstone of different aspects of business research, including quality control, risk management, financial analysis, and several others as well. Now let us look at how we can use Excel for computing the normal probabilities. We had already seen the way in which we can compute manually. However, that also requires more involvement of Excel. So let us take the help of Excel and compute the probabilities. Now this is the Excel function with the help of which we can compute the probability of the random variable to have a value less than equal to x. So this is the name of the random variable x and this is the value. For example, probability of x less than equal to this may be like 2.5, something like this, or whatever is asked for. We'll see in later case. So here I have to write that value 2.5, 2.5 say. Suppose the mean is 10, so I'll write here 10. Sigma is say 1.2, 1.2, and then true. True will give me the cumulative probability. That means probability from minus infinity to that point, say 2.5 is there. So till 2.5, that part of the curve. That means if it is 2.5, then this area, this probability is nothing but area under the curve, normal distribution. So you have to put this equal to, you know that in Excel, if you want to use a formula, every time you have to write equal to, then norm dist, then x mu sigma, and then you write true. So that will give you the probability. We take an example. Let me wrap this off. So So suppose we have an example of computing the probability of x less than equal to 20. And suppose the mean mu, that is the mean, is given to be 18 and the standard deviation is given to be sigma. In this case, what we have is that we write equal to norm dist, since x less than equal to 20, so we write 20. Then we write mu, that is 18. Then we write sigma, that is 4, and then we write true. So once we do this, then this gives me the probability up to 20. Probability of that random variable x up to 20. Now sometimes it may so happen that the probability is given to us and we want the value of x. That means the value of x for which the value of the probability is attained. This is called as the quantile. That means when probability is given and we reverse, we want to get the value of x. We'll see some examples when this becomes very useful. That is called as the percentile. So we have to, not quantile, sorry, percentile, and the probability of x, then probability is given, then we have to find x. So that is norm equal to norm. You see, this is the comment, equal to norm, and then you write inverse I and v. I and v is for inverse. Don't forget to put this dot. Equal to norm inverse, then the probability. Say you want probability below 80%, so you may write 80%. You have to remember that 80% is actually 0.8. Why? Because this 80% is 80 divided by 100. So this is 0.8. So we put 0.8 here. Mu, whatever be the value of mu, and sigma, the corresponding value of sigma. No true, false, etc. is required. Okay. For that we have, see, suppose x, the probability is 70%, mu is 18, sigma is 4. Then to calculate that value of x, which has a probability of 70%, we write this norm dot I and b 0.7, 18, and 4. So that is how we get the inverse value of the probability. Next, we see the computation of probability for a standard normal distribution. In a standard normal distribution, we have mean equal to 0 and sigma equal to 1, that is standard deviation of 1. In the previous commands also, if you put in place of mean, mu, that is in place of this equal to 0 and this equal to 1, then we can get the probabilities of standard normal distribution as well. But there is a special command in Excel to deal with the standard normal probability, and that probability is given by norm full stop s full stop dist. So that is z, and then we write true here. So this is norm dot s dot dist z and true. So this gives probability of z less than equal to z. So this is how we compute the probability. Example, z is less than equal to 1.5 for mu equal to 0 and sigma equal to 1. So we don't write mu and sigma because of this norm s. Only difference is this presence of this s. So that's why we have colored it differently to explain the difference. And this true gives you the probability up to that point, from that is cumulative probability. If you write false, then it will give you just the ordinate value, which is not useful at all in computing the probabilities. Ordinate means height of the curve from the corresponding value of z. So that is not used in any type of probability computation in normal distribution. Rather, we require the cumulative probabilities from one point to the another. So this is how it works. And then here we take an example that we want the z value less than equal to 1.5. So in place of z, we write 1.5 and then we write true. And the probability is given and find the z percentile. So if the reverse, it means if probability is given to you, you have to get the percentile value of z that we have done earlier. In that case only, just you put the probability. That means someone asked to compute you the probability, the value of z for 70% probability. So just norms in and then 0.7, because 70% is 70 divided by 100, so that is equal to 0.7. So we replace 0.7 here, and that's we calculate the norms distribution. So this is how now we have a problem here which we'll try to solve. Now it is about evaluating a marketing campaign performance. A company runs an online marketing campaign. Okay, historical data shows that the revenue generated per customer from such campaigns follow normal distribution with a mean of $120 and a standard deviation of $35. The campaign costs $95 per customer to execute. Okay, this information is provided to us. So we have normal distribution. We have the mean. Okay, let me change the color. Okay. We have the mean of the normal distribution, that is 120, and we have the standard deviation as 35. And this is some value, probably this is the value of X. Maybe we'll understand later on when we read the question. What is the probability that a randomly selected customer will be profitable? Now you see, the campaign costs $95 or $95 per customer to execute. That means that is the cost. So I will get profit only if the value of X, that means what we tell, the expenditure made or the revenue generated. The revenue generated is X if X is greater than $95. So we start with this problem. We have mu equal to 120 and sigma equal to 35. That is already given. We know that. And the value of X, that is profitability, is 95. So we write that X is the revenue generated. So we get profit if the price is revenue is more than equal to 95. Now you see how these values are computed. Means this is one way we can also use Excel. Now this is some values are given to us. We'll use this value, this one, maybe this one, or maybe this one. We will see later on, and we will compute the probabilities without the application of Excel here. So what we do, 95 greater than equal to 95. Now we actually convert it to less than equal to 95 by taking the complementary event, because this will make the job easier. Because what we have is less than equal to z less than equal to, here also z less than equal to, here is z less than equal to. So greater than equal to probabilities are different to compute, difficult to compute. So we actually bring it to less than equal to. How? 1 minus probability of X less than equal to 95, that we. Now we take away the mean and divided by standard deviation, because I will convert this X to Z. So X minus mean by standard deviation. Similar treatment I have to give in the right side also. We cannot keep right side at 95 and do it. So we require this. So accordingly we get this. So here we have Z value, and here if we compute 95 minus 120 divided by 35, you will find that the value is minus of 0.714. It means minus of 0.7, 0.2375. And so it is minus 0.2375. So 1 minus 0.2375, that gives you 0.7625, that is 76.25%. So the probability that a randomly selected customer will be profitable, that is quite high, means 76%. So this is the 76%. This Z value we are writing here. This is the Z value, so that we can understand that from this point, because when you convert to Z, you have to look at a zero scale. So 0 to minus 1 is somewhere here. So here is your 7143. So this is minus 0.7143. So accordingly this point, and this area of the curve, area under this curve, that is called as the required probability in this case. So first problem is solved. Let us look at the second problem. We are to compute that percentage of customers, means actually probability, and then you convert it to percentage. Here you see first one, it is tell the probability that are randomly selected. So you could have stopped here. This is good enough. Percentage they have not told you, but so no, you may not compute this percentage. Anyways, let us go to the second one, that is B. The percentage of customers will generate revenue $100 to $150. That means your X lying between $100 and $150. So this is your X. Some marks are there from the previous competition. Let me erase this. I think, okay. Okay, now come back. Let me take which color? Yellow. Okay. So this is X. We start with this. Now we need to convert into Z, because here all the probabilities are given in terms of Z. So what we do, whatever be the value, just subtract the mean, divide by standard deviation. So this subtract the mean standard deviation. This also subtract the mean standard deviation. So this is given by minus 0.5714 less than equal to Z less than equal to 0.8571. So this is what happens here. You see, we are giving you the Z values. If you compare it in the card, you see, if you see the compare curve, you here you see have 0.8571. 0.8571 is here, this point. So I draw a line, this particular line, say I draw. Okay. And then this is, we take this value, that is 100 minus 120 by 35, that is minus 0.5714. So this is like minus 5.5714. That means I want the area probability under this particular shaded portion. But whatever information is given to me, all of them are from minus infinity, that is from this point. This point. So what I use this and I use this. How? You see, this is from minus infinity to 0.8571. That is starting from this point, this entire part. First one. Let me use a different color. Say this one. Okay. That first, this part is actually this entire area, this red area. Okay, and this is actually this green area. Say, okay, this green area, this part, this white part. Now, if we subtract the red part, which starts from here and goes up to here, from it the green one, that means this area, then we get the yellow area. So that is what we are doing here. So Z less than 0.8571, that is from this part to the end of the yellow area, minus this part to the beginning of the yellow area. So this one is this. So accordingly we get the yellow area only. So this is the value and this is the value. So accordingly I get 0.5204. So this area is equal to 52%. If you express in percentage, it is otherwise probability is 0.52 0.5204. But since they have asked us to compute the percentage, so just multiplied by 100, 52.04% approximately 52%. So this is how, without the help of Excel, we can solve this problem. But the probabilities has to be given to us. Someone has to compute the probabilities earlier and provide us. Otherwise, we'll take the help of Excel in solving it. Earlier, when computers were not there, people used to take the help of statistical tables, which is called as the probability values of Z, and Z tables are there. Even if you take some statistics book and turn into the back pages, you will find that the table of Z, sorry, table of Z is there at the back of the statistics book. Now, let us compute this. The strategic project management, this problem is related to strategic project management. Here, a project project manager is analyzing the completion time for a key business initiative. The completion time is normally distributed with mean. So here we get the mean 150. 180, with a standard deviation of 20 days. So mean and standard deviation. The project has a strict deadline with a penalty clause. That means if the person is unable to complete within the deadline, then he will get a penalty. Manufacturer or the means people who is in charge of the project. What is the probability that the project will be completed within 200 days? So first thing is that. Second is that if the project managers want to be 85% confident of the meeting deadline, what deadline should they commit to? So this is a problem of computation of the percentile. That means probability is given to you. You are to find the value of X. So let X be the number of days which is required to complete the project. We have mean equal to 180, that is mu is 180, and standard deviation equal to 20 days. Now, this is X, that is number of days required to complete the project, less than equal to 200. Now we are using Excel here, otherwise table value has to be provided. So that is equal to norm list. You can write in capital letter or small letter because Excel is not case sensitive. So 200 is the value of X. So I am writing 200. Here I have to write the mean. So that is 180. Then I have to write the standard deviation, and then I'll write true because I need the probability from 0 days to 200 days. So that's why this. And once I write this, then in Excel, we'll get the result 0.8413. That means 84.13. That is approximately, you can tell that, well, this is 84%. That means there is an 84% chance that the project will be completed within 200 days. Quite high, isn't it? Now let us look at the problem number 2. Here we have this equal to 85. That means he is given 200 days, this individual, and then to complete. So what is the chance that or what is the actually possibility that he will reach this project 200 days with 0.85, means that less than equal to. So norm inverse, here we actually take this as 0.85 because probability is given to us. So we require the norm inverse 0.85, 820. So you see this comes out to be 201 days. That means that 85% confidence with 85% confidence, he can attain the project in 201 days, not in 200 days. 200 days gives him, as we have computed earlier, approximately 84% confidence. But if he wants 85% confidence to make a statement that yes, I am 85% confident that I will finish the project in 200 days, that will be an understatement. He requires 1 day more probabilistically. So that is what is the use of the computation of the percentile given the deadline. Now there is a problem for inventory management. The next one. A retailer knows weekly demand for a product is normally distributed with mean mu equal to 100 units. So mean is there and the standard variance is there. You see, this is very important. Not standard deviation, but variance is there. So I have to take the square root of this to reach the standard deviation. Okay, after that, they want to stock enough to meet the demand 95% of the time. What should be the target inventory level B? Okay. So, well, first thing is that I define the parameters. I define that mu equal to 100 and sigma we take the square root of 225 and that is 15. So we have mean and sigma. Now I want to stock 95% of the time. That means probability is 95%. I want X. That means I require to compute the percentile. And so what is the formula? The formula is that I want to find X such that this is equal to 95. For that we use the norm inverse. So this is the value of probability 0.95. This is the mean, this is the standard deviation, and this comes out to be 125. That means the weekly demand is 125, then 95% times he can meet the demand. So what should be the target inventory level? That means target inventory level should be 125. Though inventory has a more generalized meaning, but very roughly speaking, inventory is the stock. Very roughly speaking, very crude way stock. So if he keeps a stock of 125 units of the product, whichever he is delivering, then he can satisfy 95% of the demands coming in. That means 5% of the demands will not be satisfied. He will tell that I am running out of stock. You must have seen that when you purchase different things from online, sometimes some product is shown, you find that it is of your choice. But when you click it, it tells that out of stock. That means currently that is the situation happening. Means he has produced this maybe, or maybe just kept the photograph without producing. That is also a possibility. You don't know. But plainly speaking, if you speak of and think of an ethical situation, then he has produced the product, but the number of demands were such that it has exceeded the 95% case chance, and so you are one of those unlucky 5% people who has actually clicked it after all the 95% demand which inventory has been exhausted. So, well, that is an interesting way of looking into this. Okay. Now, before we close, we let us look at the difference between the normal distribution and the other distribution that we studied. The normal distribution in the business context, it can be used to understand the variation in a process or performance level, etc. It is meant for continuous data, which is symmetrically distributed around the mean. A binomial distribution actually deals with the discrete data. It actually counts the number of successes or failure in a number of repetitions of a particular random experiment. The number of success here actually is fixed. Sorry, number of repetitions of the experiment is fixed, and the probability of success remains same throughout any number of times you repeat the trial. Poisson distribution generally deals with rare events, events which rarely happen, like failure of a machine, uh, and also for with respect to arrival and departure rates, etc. It is here the number of events in a fixed in a fixed time and space is used for modeling. So these are the basic differences between normal distribution and binomial and Poisson distribution. So binomial Poisson distribution both comes from the discrete family of distribution, where the random variable x is count data, that is number of times an event occurs, etc. And normal distribution comes from a continuous type of data like height, weight, performance level, demand, supply, etc. So this type of things. Okay. Some of the real world execution problem, though we started with some of this as well, but more specifically, risk management. This is a very popular subject of risk management, especially risk management related to portfolio analysis. Yeah, normal distribution means without normal distribution, you cannot work actually in risk management. Then in production system, that is in quality control, we speak about the Six Sigma control limit. So this is which actually studies the variation in the quality of the product. Based on that, we develop the Six Sigma control limit, and we assume that the variation in the quality of the products will range within the Six Sigma control limit. That means mean minus 3 sigma, mean plus 3 sigma. So within this range, we expect our product's quality to fall. If it goes beyond that, less than minus 3 sigma or more than plus 3 sigma, then we assume that the system is going out of your control and the product's quality is compromised. So you require a human intervention to check and to bring the system under control. Human capital planning using like performance analysis, with distributions of the performance of a group of individuals, we can calibrate them that these are the top performer, this is the poor performer, etc., which helps in your planning, which helps you in putting the best person in the best place, etc. It can also be used for financial modeling, like projecting future revenues and cost by building models that assume a range of normally distributed outcomes. So these revenues and costs at a future, this can also be used for the purpose of prediction. So this is all about normal distribution. Thank you for watching this video. Take up some such problems that we had discussed from things happening around you or from the book, whichever you are following, and try to solve these problems of normal distribution, computing the percentiles as well as the probability. Thank you for watching this video. See you soon.